Welcome to January 5th's LeetCode Challenge, minimum number of arrows to burst balloons. There are spherical balloons tapped onto a flat wall that represents an XY plane. The balloons are represented in a 2D integer array points, where points at index I has start sub x, x sub start and x sub n. Denotes the balloon whose horizontal diameter stretches between x start and xn. You do not know the exact y coordinates of the balloon. So keep that in mind. You don't know the y coordinates. You just only know the x coordinates. The balloons can be shot directly vertically in a positive y direction from points along the x-axis. A balloon starts at x sub start and x sub n is burst by an arrow shot at x if x is between start and n. There's no limit to the number of arrows can be shot. The shot arrow keeps traveling upwards indefinitely, bursting any balloons in its path. Given the array's points, return the minimum number of arrows that must be shot to burst all balloons. Alright, for this type of question, it would be best to kind of make a drawing of it, to kind of interpret it and interpret how it works, but I can't really do that at the moment, but we'll see how it goes. So it's kind of hard to, you have to visualize basically these balloons on a XY plane, and you need to be able to kind of draw these out onto a two-dimension. So we have the balloon here. Balloon number 1 starts at so a spherical balloon. So it starts at 10 and 16, and then we have another balloon starting at 2 to 8. We have balloons starting at 1 to 6, and balloons starting from 7 to 12. So we can see if we put this on a map that we have some overlapping balloons. So basically we have balloons 1 to 6 and balloons 2 to 8. These two overlap. And balloons 7 to 12 and 10 to 16 overlap. So if we shoot a balloon, say, at 6, then you burst balloons 12, 2 and 1, 6 coordinate. And if we shoot another balloon at 11, then we can burst balloons with the coordinates 10, 16 and 7, 12. All these balloons are subsequent order, so therefore they're not overlapping. Therefore, we need one arrow to shoot each balloon. And similarly, we have balloons that are overlapping by, for instance, you have balloons coordinates 1, 2, and then 2, 3. These overlap by 2. So if we shoot a balloon at 2, therefore we burst these two. And similarly, if we shoot a balloon at 4, or shoot an arrow at 4, we burst these two balloons. That's pretty much it, the idea behind that. Constraint-wise, we have the length of the points is between 1 to 10 to the 5. And each index of the length is equal to 2, and because it has 2 coordinates. And we know that basically x start has to be less than xn, and they're between negative, the smallest number would be negative 2 to the 31st, and the biggest number would be 2 to the 31st minus 1. Alright, let's think of how to, so in order to burst a balloon, you want to find the minimum number of arrows to burst a balloon, and to me, that kind of resonates the greedy approach. So we need to find the overlapping diameter range, so that we can approach this. The first way to find an overlapping balloon to be to sort the array. So I'll just kind of walk through it as I go along. So we can sort the array by using array.sort. And we want to sort by points, and how do we want to sort it? We can sort by points. Yeah, we can do that. A couple of ways to do it. So points, we want to basically sort the x and y coordinates. We can use a lambda function here, integer dot compare. We want to compare basically the x and y. Well, it's technically start at n, but whatever. I'll say start, and we want to compare the x sub start and x sub n values, and that'll be start at 1 and at 1. So we can sort it that way. So basically, we need to find the overlapping diameter range. So the easiest approach would be to sort the array first. Then rather than sort it in ascending according to start point or end point, it's better to sort to end by the endpoints first. And we do that. Yeah, whatever. So now that we have the balloons that are sorted, we could iterate through the balloons. So we need to find basically define some variables first. So int will be our output. So these are that's the number we need to increment to the counter, and we need to define a bound as well, and that's going to be at points 0, 1. So now we have a couple of those integers defined. So we want to next do we want to basically iterate through our points.length to be able to find and counter a balloon with a start value greater than the current end value. Then we just simply make the balloon our current balloon and increment the output. So for int I equal to 1, where I is less than point dot length, we are going to increment it by I by 1. And within this loop, we want to check for non-overlapping range. So if the point at index I0 is greater than the bounds of the previous x value, then we want to update the current balloon to be our landmark, and that'll be point I1. And we want to basically increment our output because we need an arrow for that to pop the balloon. Exit this loop, and then we go to here, return output. Let's give this a little run. So points. Looks good. We see so far that this probably runs at big O n log n time. So first, kind of intuitively, we sort the array to find overlapping diameter ranges, and we sort it by basically start and end. And we define a variable called output, where we basically, that's how many arrows we're going to use, and we want to find the bounds of our current diameter, which is currently the first point. So we'll iterate through each length of the points in our length array, and then if we check to see if it's non-overlapping or not. If it's not overlapping, then we basically update the current balloon to the new balloon, basically at the start value, and then we increment our arrow count. And then just basically keep on going over that until we run out of balloons, or diameter, I should say. And then we just return our count. So time complexity wise is big O of n log n, because every time we do n times, we have to find the bounds as well. Space complexity wise, we sort the array. So I believe that it is constant memory. Alright, that's it. Have a great day, guys.